record. All right, cool. So we are talking about hashes today, this afternoon, and hashes are a type of collection in Ruby. And the collection that we've already been learning about or already been using is arrays. So what I'm going to do today is I'm going to talk about hashes and sort of compare and contrast them to arrays as we go. So in Ruby, a collection is how can I define this without using the word collection? In Ruby, a collection is like a container for bits of information or a collection of data points, a collection of information. And the two most common types of collections that we work with are arrays, which we've already been working with, and hashes. And we're going to be like starting to build in more hash work starting from today. So just to start us off, I've got these two examples, an example of an array and an example of a hash. And both of these examples are sort of trying to model the same thing. I'm trying to create a collection for a grocery list. I'm trying to create a grocery list. And so I have a grocery list that's an array on the right side and a grocery list that is a hash on the left side. So I want you to take just a minute and sort of like think about some pros and cons of both of these grocery lists and think about them that individually for just like 30 seconds to a minute. And then I'll ask some folks to share like what are some pros and cons of these two grocery lists. Think for a few more seconds about these two grocery lists. And I'd love to hear some thoughts. Who would like to share some thoughts with me? Mitchell, go for it. What are some thoughts that you have about these grocery lists?
The array is going to kind of get redundant and become more difficult to iterate through.
Cool. The array is a little bit redundant. Maybe there's some difficulty in iterating. I like it. Who else wants to share? Noah.
I like with the hash, you can store relevant information about a category of thing. It helps make your lists a little bit more detailed.
Yeah, it's like I'm not just storing all the things that I want, but I'm storing like sort of a pair of information, the thing that I need to buy and the quantity of that thing. Cool. Let's go to Aaliyah and then Richard.
I was actually going to say something similar, like the key information about the grocery list, like how many eggs you want. In the array, you'd have to iterate through it to get that versus just like calling the value in the hash.
Cool. Yep. Richard, do you want to add to that?
No, Aaliyah actually said exactly what I was going to say. I noticed that there's like 6 entries of eggs in the array, whereas the grocery list for the hash is saying that there's like 6 eggs, 1 avocado, 10 tortillas, 1 milk, and it's nicer, neater, more contained, more contextualized.
No, I love that word, contextualized. Great. Lawrence, did you want to add to that?
I'm going to hit all the buttons at once.
I like it.
I had a question about if you, con-wise, I couldn't think of a cons in the hash. What would you say there are cons to that? What would you say were cons to that?
I don't think that there are too many cons to the hash, maybe none. So y'all touched on like the big piece that makes a hash different from an array. And this is this idea that like Richard called it like contextualize, I think is the word you use. Like it gives it context. It gives your list some more context. Looking at the array, if I need to see like how many tortillas I want to buy from the store, I like, my human brain has to like look through and count like how many tortillas do I want? 1, 2, 3, 4, 5, 6, blah, blah, blah. It's like harder for me to understand all the things, all the information that I can glean out of this array, versus with the hash, I have some more context around each of these things. I have more information about like how many tortillas I want. So both of these collections, if I handed anyone both of like one of these two collections, they could probably go to the grocery store and get me the things that I wanted. The person that got the array handed to them would probably be a little more frustrated than the person that got the hash handed to them, right? So both arrays and hashes are collections. So collection of data. And I can like say, yep, this is a hash is also a collection of data. Let me make this line up a little bit more. There we go. So they're both collections of data. An array is specifically like a list of things, data points, elements is what we actually call these. So an array is a list, like a list of single data points, single things. When I say list, like what this means is that this array has like a specific order. Arrays are ordered, and we'll get more into that in just a second. A hash is a collection of data, and it's more specifically a collection of, I'm going to call this like paired info, or key, let's see, how do I want to write this? Key value pairs. So a hash is made up of key value pairs. An array is made up of single elements. So the elements in this array are like this string milk, string eggs. Each of these is an element in this array. In our hash, each key value pair is this string pointing to this amount. The key of milk pointing to the value of 1. It's a collection of key value pairs. And this collection is unordered. And we'll talk more about what that really means in a sec. Ordered, an array is ordered, a hash is unordered. Cool. Many languages, maybe all languages, I'm not 100% sure, but this idea of having pairs of information, key value pairs, is very common. And so you'll see similar data structures in lots of different languages. In other languages, they're often called dictionaries because you look up some information based on some other value or some other label. So just like in a dictionary, if you need to look up the definition of milk, in our hash, if we need to look up how much milk we have, we look that up based on this little bit of information here. So we use our keys to look up information in our hash. Sarah, did you have a question?
I do, yeah. Thanks for getting to me. Just so I'm understanding the left to right comparison here, avocado should be listed once on the right-hand side, correct? Or am I missing something? Just because like there's 1 milk and then there's 6 eggs. I just wanted to make sure because I was like,
sorry.
Okay, perfect. Thank you.
Yes, good call. As I read through this array to try and build this hash, it was so difficult to read through. I couldn't count. Yes. Yes, thank you for that clarification, Sarah. Cool. Yeah, so just to be super clear, I'll just put a note up here. This is the key points to the value. And each of these key value pairs separated by a comma. That's how you know when one starts and stops. All right, cool. Yeah, so some languages call these dictionaries, just something nice to know. The other thing that you might notice is we start these hashes differently than we start an array. To start a hash, we use a curly brace or curly bracket. I never know what the actual word for this is. I think it's curly brace. So the squiggly line, hash, squared off line, array. Okay, so that's a key piece here. Let's see. There are a couple of rules around using hashes and working with hashes, and I'm going to go over them before we jump into actually like creating them and all that stuff. So if we think about an array, what are some of the rules of an array? There's like not too many, but a rule could be, let's say, let's do this, rules. What are some rules of an array? Elements can be any data type. Elements can be any data type. They can be a string, they can be a number, they could be an instance of an object, they could be another array, they could be a hash, they could be any data type. Apologies if you can hear that siren. Some rules for a hash. Rules. Let's see. How did I format this? We'll try and make it the same. Keys and values can also be any data type. Wow, I cannot type today. So keys and values can be any data type. Little bit of a caveat on this. Keys are almost, okay, I'm going to say keys are usually strings, symbols, or instances of objects. Okay, so keys are usually strings, symbols, or instances of objects, but they can be any data type. There is one rule though, keys must be unique. Unique. Oh geez. Keys must be unique. We cannot have two keys called milk. And if you think about it, if you think about how like a dictionary works, this makes a little bit of sense. Like you don't have two entries for milk in your dictionary. Okay. Keys must be unique. And we'll talk a little bit more about that, about why that is in just a second. But Natia, did you have a question?
Yeah, I realize this is probably covered like way back when, but can you go over what a symbol is?
We will actually go over it a little bit later in this lesson.
Okay. All right. Thank you.
Great question. For now, just think like a symbol is another data type. So like strings, integers, floats, symbols, all basic data types in Ruby. And we'll go over more of that a little bit later today. Noah.
Do we get a helpful little error if we try and assign two keys as the same?
Not really. Well, I'll show you sort of what happens with that once we actually get to playing around with some of these things. But yeah, no, not really. Sammy.
So I noticed when you were pointing out the syntax for both a hash and an array, you mentioned the curly brace for the hash. In the past, when you've called hashes, you've needed to use, if I'm thinking of like the same thing, an octothorpe before the curly brace. But so when you're calling one, you need to use one of those, but when you're actually listing your keys and your values, you don't need an octothorpe in front of the curly brace. Does that make sense?
I don't know where the octothorpe is coming from in your.
I think she's getting confused with interpolation.
Yeah.
Oh. Thank you, Alex. Yeah. So yeah, this is a totally different thing. So string interpolation might look something like this. Go get me everything on this grocery list. So this syntax where it's like octothorpe curly brace, this is saying inside this string, insert whatever the return value of what's inside of here. Yeah, different. Yeah, totally different.
So this is just, so that's not actually called a hash, the go get me, and then, so
yeah, this is not a,
okay.
Yeah, this is not a hash. I would say if I was gonna like read out this line in like code speak, I would say in a string, in the string go get me, interpolate the value of grocery list, this variable grocery list.
Okay,
Yeah.
thank you.
Sort of like an insertion method. Yeah. Oh, that's confusing. That's confusing. Yeah. Sorry. I don't know how to make that better.
No, that was, thank you.
Okay. Yeah, that's confusing. Okay. Was there another hand up? Maybe someone's going to put a hand up and tell me I need to plug my computer in.
No, I was just going to say what Alex said.
Okay, cool. All right, great. So some rules. Let's see. Keys and values can be any data type. Keys must be unique. Let me see. Is there any other? Nope, that's it. Okay, sweet. So why do we even like have this idea of collections? Like what purpose does it serve? And it really serves like two main purposes. One, to store data, and two, to give us the ability to easily access bits of that data that is stored. So collections, like their usefulness to us as developers is their ability, or is the ability that they give us to access specific bits of information. So if I have an array and I need to access a specific bit of information, I access that information. So I access specific elements using square bracket notation and the index of the element I want. And so what that looks like is like if we have grocery list, square bracket 3 will give me 0, 1, 2, 3 will give me this eggs value. Okay. And this is really where the order of arrays comes in. Arrays are ordered so that we can look at an array and know how to grab a specific element out of that array. If I want this eggs, I want the 0, 1, 2, third index in that array. So this is what we mean when we talk about how things are ordered. Okay. Hopefully this is like a little bit of review. With a hash, to access, I'm just going to copy and paste this and then change it as I go. To access specific values, using square bracket notation and the key of the value I want. So instead of grocery list 3, if I want to see how many eggs I need, I'm going to say grocery list egg. So I'm using the key to access a specific value. So with an array, you basically need to like be able to see the whole array in order to grab any bit of information from it. If you want a specific thing, right? I need to know where this egg is in order to access it. With a hash, it's more important that I know what the keys are. So I use the key to look up a specific value. Okay. We're going to get more into this later, but this is where the difference between ordered and unordered comes in. Because a hash is unordered, I don't want like the 1, 2, 3 third thing or the 0, 1, 2 index thing. That's not really a concept that exists in hash structures. we use the keys to access specific values. There is no order to a hash. Okay. Questions so far? Okay. My video has been a little bit choppy for me. Am I very choppy for you all? No? Okay, great. Let me know if that changes. Okay, cool. So we've sort of gone over like the basics of hashes versus arrays. I think we're at a pretty good point to take a quick palm. Let's come back at 228 and we'll talk about how we create and use and manipulate hashes. So we'll come back at 228. All right. So before the palm, we talked about just some like basics of defining hashes and arrays and sort of talking about the differences between the two. So let's actually jump into some code and start playing around with these two things. The first thing I want to talk about is how we actually create these two different collections, these two types of collections. So I'd love to see with like fingers, with your fingers, your physical fingers, how many different ways do you know of to create an array? How many ways are there to create an array? I want to see with like with your fingers. Are there 0 ways? Is there 1 way? Are there 2 ways? 4 ways? 3 ways? Cool. I'm seeing a few I don't knows. I like it. Can I hear from someone, what is 1 way to create an array? Molly.
You can just use the square brackets for an array.
Cool. Square brackets. Great. I like it. That created an array. So I'm going to take this, I'm going to put it in my create. So here's like, here's 1 way. And I would call this creating an array literal. Array literal. So I use the literal, I like literally type an array to create it. Cool, I like it. What's another way? Joe.
Yeah, isn't it like array.new or array.new or something?
Cool. Array.new. Yep, I can create a new instance of the array class. I like it. So this is another option for creating a new array. I don't know if I have a special name for this, but just calling array.new. Okay, I like it. Does anyone have another way to create an array? Brant, I'm very curious.
Yeah, I'm curious if this is a way or not, but the map enumerable creates an array, but you have to have an array to do that though. So I don't know. Maybe that's not what you're looking for.
Yeah, I like where your head's at though. Like that is a way that creates a new array, but I already have to have an array to call map on. Yep. Joanna?
Okay, now that I raised my hand, I don't know if this is a real thing, but
That's
like
okay.
if you did like dot to underscore a, like can you do that? Like convert to an array?
I can, but if I do something like dot to a, I need to like call that method on something.
Okay.
Yeah, I can't just call it on the main Ruby object. I would need to call it on like some string or something. Yeah, I would say that the two ways that I know how to create an array are the two that have been said already. There definitely could be other ways, but these are the two ways that I see most often. So the like creating an array literal and creating an array with capital A array dot new, creating an instance of the array class. Now, just to be super clear, these two arrays are the same thing. They're not literally the same objects, but they are equivalent to each other. So array 1 is equivalent to array 2. So two ways to create the same array. Okay. Similarly, there are a couple of ways to create a hash. We can create a hash literal, and that is very similar to the array. We're going to say hash equals empty curly brace, and that will create a hash for us. It's an empty hash, but it's still a hash. So we can do the hash literal. Make my notes here. Or I can do hash.new. And this will also give me a new hash, which is, oh man, I meant to call that hash 2. Darn it. Anyway, it will also give me a new hash, and those two hashes are equivalent. You'll just have to trust me on that for a sec. Dane, did you have a question?
Yeah, do you mind just scooting the terminal just up a little bit?
Oh,
it's
yes,
kind of
I'm
cut
sorry.
off just a little bit. Thank you so much.
Yeah. Let me then also make this a little bit higher. There we go. Cool. Yeah, thank you. Thank you. Sweet. So two ways to make a new hash. Alex, did you have a question?
Yeah, and I can save it for later and re-ask it, but how do you create a hash with the default value of 0 in the first way you made it a hash? Because I was doing the Ruby exercises and it was like, nah, yo, screw you.
Yeah, ask me again later once we talk about the default value.
Okay.
Please, thank you. Cool. Any other questions on how to create this like empty hash? Yeah, Gunnar.
I'm not sure if it necessarily calls on making a hash, or like when you're calling on like making a new hash, but when like you create a test and you have an empty hash, it doesn't like when you just have empty, like just the curly braces. It likes it when it has it in parentheses. Why is that, I guess?
So I'm going to replace it in that sentence with mini test. And since we are learning RSpec, there's going to be some differences. So cool. Yeah, okay. We'll talk more about hashes and RSpec probably after the next independent challenge. Yes, we're going to design some struggle for you. It's going to be real fun. Alex, did you have another question? Oh, no, okay. Okay, cool. So yeah, this is how we can create just plain old empty hashes. But empty hash is not super useful. Like what's more useful is if we have a hash that actually has stuff in it. So I'm going to go ahead and create a hash, and I'm going to call this hash suitcase. And my suitcase is going to have, let's see, 4 pairs of socks and 1 pair of jeans, and that's it. Okay, so I just used the hash literal notation to create this hash. So my suitcase is now this hash with 2 key value pairs in it, socks 4 and jeans 1. Sweet. So let's talk about how we like use this hash. Like how do we actually get information out of it? We saw like the general syntax for getting information out of a hash in the notes here. But if I want to see like how many socks I have in my hash, I need to ask my hash to give me the value that is at a specific key. So I want to see what's the value at the key of socks. And I need to use the exact key. So this is a string socks. I'm going to ask for the string socks. Yeah, I think that's all I want to say about that. Let me ask a question. If I wanted to add something to an array, what is one method that I could use to add something to an array? Lawrence.
Dot push.
Dot push. Cool. Yeah, dot push will add things to an array. So I'm going to make a couple notes here. To add to an array, we could push whatever the thing is or the element that I want to add. Great. Sammy, did I see your hand up?
Yes, I was just going to say dot push or shovel.
Yeah, cool, great. Or shovel the element into the array. Yep, both those things will add something to our array. Yeah, Joe.
And isn't unshift another one?
Yeah, and can you describe like what unshift does?
I believe it adds it to the beginning of the array instead of the end.
Yeah, I think that's right. Yeah. So we could also add things to the beginning. I'm going to say though, like, and why I put this in parentheses, we hardly ever do that. Because an array is ordered, it generally makes the most sense to add things to the end of the list instead of the beginning. So like hardly ever do we use this method, but yeah, it does exist. But yeah, push and shovel, this is how we generally add things to an array. Now, because a hash is unordered, there's really no like end of the list or beginning of the list. There's just like the box with key value pairs rumbling around inside. And so with a hash, we don't have a nice method push or shovel to get things onto the end of our hash because there's no end, there's no order. So what we do instead with a hash is we declare new keys and values in the same way that we declare variables and what they should hold on to. So I'm just going to make a note of this. To add to a hash, we declare new keys and set their value in the same way we declare new variables. And the way that we do that is with the assignment operator, which is equals. Okay. So if I wanted to add like some shirts to my suitcase, I would say, okay, hey suitcase, go ahead and let's declare a key of shirts. And I want to make that key point to a value of, I don't know, 3. I need 3 shirts. So this looks pretty similar to how we would declare a variable. The difference is we're telling our suitcase what key should be declared with the bracket notation. So we're saying, okay, hash, at this key of shirts, I want to set the value equal to 3. So when I run this, I can double check that it worked by looking at my suitcase. And now I have socks, jeans, and shirts. Questions so far? Yeah, Noah.
Is that also the process for reassigning key?
Yes. Yep. Yeah. So if, and I think, was it you that asked about duplicate value or duplicate keys? I can't remember. Someone did, but this is sort of related. So let's say I wanted to like have another key of jeans, right? Like I might try to do something like jeans equal to 3. Like maybe I think that I should have like 2 keys of jeans. This is not going to give me an error. It's not going to say like you already have jeans in your suitcase. It is simply going to reassign that key value pair. So now if I look at my suitcase, jeans is 3. I have said, hey hash, at this key of jeans, make that equal to 3. Yeah, great question. Okay, so again, you cannot have duplicate keys. So if you try and set a value to a specific key that already exists, it's going to get overwritten. All right, let me take a look at our list here. Yeah, Sid, did you have a question?
Will it get overwritten in the test or from a test, or would it just be in your class?
Will it get overwritten in your test? It depends entirely on what you're doing. Yeah, sorry. Okay. What do I want to do next? Okay, so one thing that happens quite frequently when you're working with hashes is you will frequently want to try and access a key that may or may not exist. So if you are trying to like access a key that doesn't exist, let's say I look in my suitcase and I want to see how many sunglasses I packed. What do y'all think this is going to return to me? Do you think it's going to be like an error? Like, oh, that key doesn't exist? Do you think it might be 0 because I have 0 sunglasses in my suitcase? I think it'll be something else. Let's see. It's nil. That key does not exist. It is nothing. And how do we represent nothingness or non-existence in Ruby? With nil. So if we try and access a key in a hash where that key does not exist, it will give us a default value. And that default value is like non-existence, it's nil. So when we create a hash, by default, it will give us nil when we try and access keys that don't exist. Sometimes though, we want to tell a hash like, hey, I wish you would have a default value of 0 because I might want to do something like this, where I say, okay, I know that I've got this suitcase. I can't remember if I put like shirts or sunglasses in here. So I want to just like add 1 to whatever this is. Like, I know that I want to pack this pair of sunglasses that's in my hand. Can't remember if I already have sunglasses in there, but I definitely want to add this one. So I might want to say like sunglasses plus equal 1, not knowing if I have sunglasses in there or not. And if I try and do this right now, because the default value of any key that doesn't exist is nil, I can't do things like math to it. I would have to first check, like, does it exist? If so, add 1. If it doesn't exist, make it equal to 1. So I'd have to do some sort of like if, like branching logic. This is such a common problem that Ruby has a way to tell a hash to have a specific default value. Now, there's a very easy way to do this when you first create a hash, and I'll show that to you in just a second. But there is another way to do this once a hash has already been created. So I think someone asked this question before, but I can tell my suitcase, I can't remember exactly the syntax for this, but I think I can say, hey, suitcase, run this method default, which will give you a new default value. And now I want your default value to be 0. So now if I try and access suitcase at the key of sunglasses, I think this now will give me, nope, shoot. Okay, I'm gonna have to look up the method for this. Methods.sort. So many methods. Default. Oh, default equals. Okay, suitcase.default equals 0. Okay, now if I look at my suitcase, I should have no sunglasses. Okay, but now I should be able to ask for sunglasses, and yes, 0. So I've overridden the basic setup of my hash and said, hey, if I ask you for a key that doesn't exist, instead of giving me nil, give me 0. And the reason that this is helpful is because, like, with this idea of having values that are numbers, you will often want to do math with this. And so now I can much more easily say, like, even if this thing doesn't exist yet, go ahead and add 1 to it. And now if I look at my suitcase, I've got socks, jeans, shirts, and sunglasses. Okay. Let's go Joe and then Gunnar.
So is there a way to check, like, of course, with this hash, you can read through it pretty easily, but if you had a big hash, like I know with an array, you can do dot include to get a true or false. Is there something like that for a hash? Like, can you do, suitcase.keys.include or?
Yeah, you could do suitcase.keys.include. Keys is a method that you can call in a hash that will give you all of the keys in an array. So since include is a method that you could call in an array, yes, you could do this. But really the way that you tell if a key exists or not is by using that idea of a default value, which is one benefit to keeping the default value as nil, because then it becomes very easy to tell if that key exists. Okay. If the default value is 0, then I might end up like, what if I say sunglasses, like, oh, I actually don't need that one that I just threw in there. So minus equals 1. Now my suitcase does have a key for sunglasses and the value is nil, or is not nil, it's 0. Okay. So now this is like getting a little bit more confusing of, if I have a key that's returning 0, does that mean it doesn't exist, or that it exists but the value is 0? Let's go Gunnar and then Alex.
Two questions. So the first one is, you called, is that the method you can call to see other methods, like that you can call on like a hash or on an array? That was hash dot
this?
methods, right?
Yeah, so you can call dot methods on any object in Ruby, and then I just called dot sort on it because I knew that what the method that I was looking for probably would started with like default something. So I just said like, hey, suitcase, whatever you are, give me all the methods that you respond to sorted, so that I can look through and find what I think the method that I'm looking for is.
Awesome. And then the second one was, you called the method suitcase.default equals 0.
Mm-hmm.
And I've seen before, and I wonder if this is used the same way, when you do a hash dot equal hash dot new and you put parentheses 0, is that the same thing as calling like a default equal 0?
Yeah, and I'm gonna show that in just a second.
Okay, sorry.
No, all good. Let's go Alex and then Matt.
Really quickly, so when you start writing a new hash and you want that default value of 0 to be done in this way, can you just really quickly write another example?
Like this?
Was that, it would just be suitcase.default equals 0?
Yeah, so if I've,
you would start it?
it's not how I would start one if I wanted the default to be 0. I'm going to talk about that in just a second, but this is like, I've already been working with this hash, and instead of totally recreating it, I just want to tell it to have a default of 0. Yeah. Let's go Matt and then Dane.
I think I might have just missed a step here, but when you called sunglasses, there was not a sunglass key at all, right? And that's and it returned 0 because you had set the default value to 0.
Yes.
But then later, is that key now in there? Am I asking that question correctly?
Yes, you are. So at this point, I told my suitcase hash, if I try and access a key that doesn't exist, give me 0 instead of nil, which is what it would normally give me. And then on, let's see, so on this line, I'm showing, okay, yep, that default value is working. It's giving me 0, but at this point, sunglasses is not a key that exists in my hash. Okay. At this point, now because I have assigned a value to this key, now the key is going to exist in my hash. And it's going to be a key value pair of sunglasses 1.
So the sunglass got created after line 20, not after line 19.
Correct. After line 20, this is where sunglass gets created. On line 19, I'm just asking for that value, and it doesn't exist, but because I've changed the default value, it's giving me 0. Now, I did a kind of wonky thing down here on line 23, where then I said, okay, now let's minus equals 1. And now the key still exists because I've been manipulating it. I've been like assigning specific values to it. And so that key still exists and the value is 0. Not because it's a default value, but because I have been manipulating it.
Thank you.
Let's go Dane and then Alex. Oh, no, just kidding. Just Dane.
Okay, so I just wanted to confirm, when you said that the dot default is creating the value 0 for each key and a key value, like any potential key value thing, is that also changing it for the ones that were previously made for it?
No,
or are those still going to come nil? Sorry.
Yeah, no, and it's not creating anything at all. It is saying, now, if I ask you for a key that doesn't exist, instead of giving me nil, just return 0. It's not creating anything. Okay, so if let me be like really, let me do this. Maybe this will help. So I've got socks, jeans, shirts, sunglasses in my suitcase. Okay. if I look to see how many jackets do I have, it's going to give me 0 because that's the default value, but that has not created jackets in my suitcase.
Thanks for clarifying.
Yeah. Okay, sweet. So this is all like, I have already been working with this suitcase and I decided later on that I wanted it to have a default value of 0. If I know going into this that I want my suitcase to have a default value of 0, I would do this entirely differently. So if I know from the onset, like from the outset, from the very beginning, that I'm going to have values that are integers and I want them to default to 0, like if I ask it for a key that doesn't exist, I'm going to do this totally differently. And to show that, I'm going to exit this pry session and just start all over. So let me drop into pry again. So this is sort of like the 2A version of creating a new hash. So we've created hashes with hash literal. We've created them with hash new. This is sort of like an addition to this hash.new. I can create a suitcase like this, hash.new, and give new an argument of 0. And this argument is going to be the default value that I want this hash to have. So now instead of my suitcase returning nil as it like would do at its most basic form, if I ask for a key that does not exist, it's going to give me 0. So this is sort of a 2+ way of creating a hash. Okay. So now this hash, when I ask it for a key that doesn't exist, it's going to give me the default value of 0. Yeah, Lee.
And so the point of that would be like knowing, oh, I'm probably going to want to add like shoes. You can just use that plus equals operator versus having to like go through a different process.
Yeah. So now instead of having to check like, hey, does shoes exist? If so, add 1. If not, make it equal to 1. I can say suitcase, I don't care how many shoes you already have in there. Let's just plus equals 1. And plus equals 1 and plus equals 1 and plus equals 1. I love shoes. How many shoes are in my suitcase? 4.
Awesome. Thank you.
Cool. Any other questions so far? Yeah, Joe.
So just seeing that, would there like maybe be a scenario where you want to set the default to 0 so that if something was called that isn't in there, instead of getting nil, you get 0, so it's a truthy value instead of falsy?
Ooh. That's interesting. That actually might be a case where I wouldn't want to set a default value, because probably when I'm checking things like that, probably I'm trying to check to see if like it exists. And I would rather it be falsy if it doesn't exist. Here's the thing that I'm going to say. I tend to not use default values very often. I tend to do the extra steps of like checking with some condition or some branching logic to see if a key exists rather than using the default value. It's just a me thing. That's not a thing that everyone feels. I would say Bob probably feels the opposite, because as we talked about earlier, like Bob is strategically lazy and I want to control every line of code. So there's really like no one right way of doing it. It's more about like understanding what some of the pros and cons are of each approach. Let's go to Natia and then Richard.
So my question is kind of feeding off of your whether you do it or not. Let's say you had an example where you needed 16 hash objects with the identical value, would you therefore say default them all to this and not even set their values, or would you go through and do them one by one?
I would probably go through and do them one by one, because I want to convey to other developers that I specifically want this hash to have these 16 keys pointing to these 16 values. They happen to be the same, but I want 16 of them.
Thank you.
Specifically.
Yeah, so kind of what you were saying, Megan, about the default value. I actually didn't think that that would be a thing for a hash. And imagine a use case where with your shopping cart and you had, let's say, a key being apples and it doesn't exist, and you say the default value is 0, or maybe even like -1, then contextually speaking, you have -1 apples. Can kind of be a little confusing whether that key is actually giving you a legitimate value. I like nil, and I like null. It helps.
Yeah, I think that there are a lot of cases where I want to rely on that nil to tell me like very clearly, this thing, not just is it a key with a value of 0, but it is a key that does not exist. Often I want that. There are some cases where the thing that I'm modeling, the collection that I'm modeling, is so, maybe straightforward is the wrong word, but like so focused on the math and the counting piece, where the default value is helping me more than it's hurting me, where the pro like outweighs the con if it's like a true counter. Now, I would probably never start a hash with a default value of -1 or a default value of 3. That's just very confusing. If you're going to start something, start at the beginning. Start at nothing, which is 0 or nil. Cool. All right. Let's go ahead and take another palm. And when we come back, we're going to talk about iterating over a hash. So let's take a palm. When we come back, we'll talk about iterating. Let's come back at, let's see, 308. Let's come back at 08. Okay, so before the palm, we talked quite a bit about accessing specific values in a hash. I think the key pieces are that we like access specific values using square bracket notation. So similar to an array, but instead of using the index as we would with an array, we use the key that we're trying to access, the key for the value that we're trying to access. Okay. So I said at the very beginning, hashes and arrays are both collections. And I've talked about how collections are, well, I've talked about like when we iterate, we're generally working with collections, not generally, always. We're always working with collections when we're iterating. And so iteration is something that we are going to be able to do with both arrays and hashes. So if we think about how we typically iterate over an array, let's see, to iterate, we generally have something like this, where we have the array that we want to iterate over, and then we call like .each or map or find all or some other enumerable, and we iterate over each element. Why is all the podcasts happening right now? Weird. Okay, we iterate over each element in the array, like do something, and then end. So this should look fairly familiar, hopefully, like pretty familiar. So we can iterate over arrays with each or any other enumerable. And iterating over a hash actually works like pretty similar. Oops, not end. Like that. Where am I going? To iterate. So with a hash, we can iterate again with each or any other enumerable. And the difference here comes in our pipes. So let me finish this. We're gonna like do something. When we iterate over an array, we iterate over each element. So we have one block variable because arrays are collections of single elements, single things separated by commas, right? In a hash, it's a collection of key value pairs. So it's a collection of sort of like two pieces of data tied together. And so we iterate over a hash, or when we iterate over a hash, we can actually use two block variables to represent the key and the value. So we can have key and value in here instead of just one thing representing the element. So as we iterate over a hash, we have access to the key and the value. Okay. So what this looks like, actually, let me add a couple of things to my suitcase here. Let's add some shoes. Oh no, we already have shoes. Shirts equals 2. Let's say jeans is 1. Okay, cool. So now my suitcase has a few different things. So I can iterate over my suitcase. And here in my block variables, I can have a key and a value variable. Now, just as I would not name this block variable element as I iterate over the array, I would name it like something more relevant to what I'm actually doing. I want to give these block variables names that are more appropriate. So instead of key and value, I might do like item and amount. So just like with our array, this block variable can be anything you want. Could be muffin, could be zebra, could be key and value, but it should be something more appropriate. So my keys in this case are like items of clothing, and my values are the amount of that item that I need. So I'm going to call them item and amount. And just so we can see how this works, let's go ahead and P. I need, oh geez, that won't work. I need, and I'm going to use string interpolation here. So I need amount item. This might look a little bit weird, but we'll go with it. So I can use these block variables in my block to do things, and we'll end this. And now I can see I need 4 shoes, I need 2 shirts, I need 1 jeans. Cool. So the big thing here is when we iterate, we can use 2 block variables, the first representing the key, the second representing the value. Other than that, iterating over a hash works the same as iterating over an array. You can use each, you can use any enumerable. Let's go Lee, then Gunnar, then Caleb.
So each returns the original array. Will it also
Yes.
return the original hash?
It does. So here you can actually see the return value of this each that we did.
Perfect.
Yep. So each returns the, yeah, I guess I would amend the original statement. Each returns the original collection. Each returns the original collection. Gunnar, and then Caleb.
Sweet. You basically answered my question that it just returns returns itself, or like data collection. Is that same with if we use, say find all for the hash? Is it going to return a new hash in that case that you find that you're like finding all these in?
It's going to depend on the enumerable. I think specifically find all will always return an array of things. So you'll have to play around with it. Yeah.
Okay, perfect. Thank you.
It will depend. Let's go Caleb and then Joe.
Hello. Let's say I was feeling a little spicy and I was like, okay, dot each do key value. And on the key, I'm calling dot include shirts. And then under that, I'm doing value dot include 4. Is it basically going to go through the keys, create a new array, through the values, create a new array, or is it going to read both, and whatever both of those equal to true, that's going to go into the new array, or hash, I should say?
So I'm going to start from the beginning and say, as you iterate over these, if you call key.include, it's probably going to error because include is a method that you can only call on an array, and it's highly unlikely that you will have a key that is an array.
Okay.
So like if I called key.include here, it's going to be like include is not something that you can call on a string.
Okay.
Did that answer your question?
Ish. I was just asking, like,
Ish.
if we called two different methods on both of them, if it was going to create two separate hashes where the first one where the keys is true equals to true and the value is equal to true, or if it's just like, oh, let's merge.
It depends entirely on what enumerable you're using.
Okay.
With each, that will never happen because each returns the original array. It doesn't change anything. It will just do whatever you tell it inside the block. So
Okay.
yeah, it depends on the enumerable. Play around with it. Try things. Break things. Have fun.
Thank you.
Joe.
So since each will still return the original hash, but we're dealing with a hash and not an array, so you can't like make that empty array and shovel in, how would you use each to get a new hash?
Instead of
shovel it in.
Yeah, instead of an accumulator of an empty array, I would have an accumulator that is an empty hash. And I would, as I iterate, I would be setting new keys to new values in that accumulator hash.
Could you show what that looks like? I'm still not picturing it.
Yeah, let me see if I can think of a good example of this.
The boat renter IC had one.
I'm not going to dig into that. So let's say, okay, so I've got this suitcase. Let's say I want to, do I want to dig into this? Okay, let's say I want a reversed name suitcase. I'm just going to call this reverse for now. So what I want is like a new hash where the keys are this value reversed. So like sus and sh and all that stuff. Okay, great. This is going to be real useful. So I'm going to say I need an accumulator for this reversed hash, and I want this to be a hash. And so now I can, let me make this a little bit bigger just so we can see all this. Suitcase.each do for each item and value. I want in my reversed, oh dear, I should have checked to see if I knew this string method. I might not. I want in my reversed hash a key of the item dot, oh God, I hope this doesn't error, reverse, to be equal to the value. This will probably blow up a little bit. Oh, no. Oh yeah, maybe it did work. Okay, so I did the each, that returned the original, but now I can see what my reversed is. Yes. Does that help answer your question?
Yeah, that answers it. And would we even want to use each, or would map just be the better option?
It is going to depend entirely on the situation.
Okay, thank you.
Yeah. I will say, as you play around with the enumerables and hashes, many of the enumerables will always return an array. Each returns the original collection. Some enumerables will return an object of the same type as the original collection, and some enumerables will always return an array. So you're going to have to play around with it and sort of like trial and error a lot of this. Yeah, Richard.
What you just did with that dot each, I was actually reading this earlier today. That enumerable is equivalent to transform keys or transform underscore keys. Gives you the key, and then you can just return the new key for that.
Yeah, Yes, and there are lots of enumerables that are like specifically meant to be used on hashes. Yeah. Yep. So transform keys would work. I tend, to be honest, when I'm working with a hash, I tend to just use each because I know that it for sure will always work. But yeah, there's lots of really great enumerables that you can learn. Cool. All right, the big thing though here is when you iterate over a hash, you can use 2 block variables. The first that represents the key that you're iterating over, and the second represents the value. So as you iterate over those key value pairs, you can refer to them by key and value. Okay, great. Let's talk, let's see, it's 321. Let's talk a little bit about symbols. And I'm going to start this by saying, what do I want to say? So if we go back to the notes that I've sort of been building up here. So I said at the beginning, keys and values can be any data types. Keys are usually strings, symbols, or instances of objects. We're not going to get so much into the instances of objects today, but what we've been working with are hashes that have keys that are strings. I want to show you what it looks like when a hash has a key that is a symbol. And then we're going to dive into like what is a symbol and why is this a thing that we're even talking about. So I'm going to actually exit this prize session and I'm going to recreate this suitcase hash. And I'm going to set it up. That won't work. I need to be in Pry. Okay, I'm going to set this up with keys that are symbols. So instead of the string jeans, I'm going to have the symbol jeans pointing to a value, and the symbol shirts pointing to some other value, and the symbol socks pointing to a value. And I can end that. And now I have a suitcase where my keys are symbols. So a symbol is this thing right here, starts with a colon and then has some words, has some letters. If I want a symbol with multiple words, I can use an underscore. So like, hello world, that is a symbol. Or I could use quotes in here. You won't see this as often, but I need to show you just in case. That's also a symbol. So this is another data type in Ruby. So integers, floats, strings, symbols. These are all base data types in Ruby. Alex, do you have a question?
No matter if you use a symbol or a string, when creating the key value pairs, you're always going to use that rocket if it's in the curly brackets, right?
No. You can always use the hash rocket to create these key value pairs, but I'm going to show you one shortcut specific to symbols in just a second. But what I want to say before I get to that is we've got this suitcase. It's got keys that are symbols. I'm going to clear this a little bit. Let's get our suitcase back. So if I want to see the value at the key of shirts, I now need to use not the string shirts, but the symbol shirts to see what that value is. I need to use exactly the key that exists. If I try to ask for the string shirts, it's going to give me nil because that key, the string shirts, does not exist. So just to be super clear, the string shirts is not the same as the symbol shirts. Okay. Okay. Yeah, Mark.
So that represents a different key, right? So you can still use it if it's.
Yeah. Yeah, I could tell my suitcase to have a key of the string shirts and set that equal to something. And now in my suitcase, I have symbol jeans, symbol shirts, symbol socks, string shirts. Now, I'm going to say it's most common when you have a hash that all of your keys are the same data type. Most common that all of your keys are going to be the same data type. So I would look at this and be like, did you maybe just not realize that you had the symbol shirts or the string shirts? Like, this feels a little bit weird. But yeah, these are two different things. So you could do this. Sarah.
In which situation would you use the symbol shirts versus the string shirts? Similar to what we've been doing with the like instance variables and like calling the methods on it and stuff?
Yeah, great question. So most often out in the real world outside of Turing, most often you will see developers reaching for symbols over strings. They will use symbols first and strings only if absolutely necessary. So most often when you're looking at this kind of like character-based key information like shirts, socks, jeans, most often it's going to be a symbol. We're going to talk about why in just a second, but it will most often be a symbol. And who asked this before? Alex asked about creating hashes and like needing this hash rocket. So we've seen how we can create a hash by setting the key, using the hash rocket to point to a value, comma, key, hash rocket points to a value, comma. And you can do that with keys that are symbols. Like I did that above. I can't get to it because I cleared this, so I can't scroll up. But you hopefully saw how I did that. Now, it is so common that a hash is created with keys that are symbols that there is some syntactic sugar or a shortcut, a shorthand way of creating a hash when the keys are symbols. And it looks like this. Hash, we'll call this the sugar hash. It might look something like this. The symbol A pointing to the value 1, the symbol B pointing to the value 2. And so the shorthand is to move the colon to the right side, no hash rocket value. So the symbol A is pointing to the value 1. The symbol B is pointing to the value 2. Now, when I hit enter, Ruby is gonna evaluate this into the long form. So symbol A, hash rocket 1, symbol B, hash rocket 2. So Ruby evaluates this into the long form, but I can use this shorthand, the syntactic sugar, to create the hash with less typing. Okay, so this works just as well as like regular hash, symbol A pointing to 1, symbol B pointing to 2. They both evaluate to the same thing. Okay. So this is just shorthand for creating a hash when the keys are symbols. This only works when the keys are symbols. Okay. One other thing that I want to touch on before we dive into symbols themselves is, let's see, so I've got this, oh, I should have done this a little bit differently. I'm just gonna call this like other, I'll just call it other. What if I have this, A is 1. So is this regular hash the same, equivalent to this other? So this regular hash that I created in the long form that was evaluated to this is it the same thing as this other? Is it equivalent to? Give me a thumbs up if you think it is equivalent to, a thumbs down if you think it is not equivalent. So is reg hash equal to other? Yes, this will give me true. No, this will give me false. Cool. I'm seeing a good mix. True. These two things are equivalent. So because hashes have no order, when Ruby is looking at the equivalency of those two things, Ruby is looking at, does it have the same keys pointing to the same values? Does it have all the same key value pairs? Not necessarily in the same like order, but does this key value pair exist? Yes. Does this key value pair exist? Yes. Cool. Just a quick note on that. Richard, did you have a question?
Yeah, just real quick. What would happen if you did reg hash dot equal question mark other? Just curious. Sorry, it's just EQL.
Oh, EQL. I don't
Question
know.
mark other.
It's
Okay.
true.
Interesting. All right. I just wanted to see.
Cool. Okay. We've covered all of the things that you will need to know about hashes in order to successfully promote from mod 1. So how to create a hash, how to access things out of a hash, how to add new things to the hash, how to iterate. I can't get that fourth finger up there. How to iterate over a hash, and the idea of like symbols and like some stuff about like how to create a hash with symbols as keys. I'm going to talk next about why symbols are preferred over strings. And this is a piece that is interesting and cool to know and not something that you absolutely have to know in order to promote from mod 1. So the stuff that I'm about to say next, if it's feeling like I don't know what the heck you're talking about, that's okay. Okay, this stuff is like extra nice to know. Good research topics if you're like feeling like you want to research more about things. Okay, does that make sense? Okay, cool. So I said earlier that developers like out in the real world will always sort of default to using a symbol when trying to represent some like bit of characters. And the reason is because, well, the short reason is because symbols are easier for Ruby to compare against each other than strings. And the sort of like programmees, the codies talk that you might hear around this is that symbols are immutable. They cannot be changed. Strings can be changed. Symbols cannot be changed. So what does that actually look like? Like how can we wrap our minds around this? Let me clear this out. If I create two strings, I'm going to call this hello 1 is the string hello world, and hello, oh my goodness, I cannot type. Hello 2 is also a string hello world. These two things are equivalent. Hello 1 is the same as hello 2. Okay. But how is Ruby determining their equivalency? So these strings are equivalent. They have the same value, but they are not the same object. So hello 1 is this object that ends in 0520. And hello 2 is this object that ends in 2660. So these are two different objects. Okay. Ruby compares to see if these two things are the same by looking at each character in both strings. So Ruby says, is the first character the same? Yes. Is the second character the same? Yes. Is the third character the same? Yes. Is the fourth character the same? Yes. And on and on and on and on until Ruby either gets to the end of both strings at the same time and everything has been the same, or Ruby reaches something where it's like, nope, now these two things are different. Okay. And that process is like slow, very slow. I mean, it's not something that we can detect the slowness of, but it's slow. Versus symbols, which behave a little bit differently. So if we have, let's just call this like sim1 equals hello, and sim2 equals hello. These are actually the same object. So these are both the objects ending with 8268. These are the same objects. We're pointing to the same location in memory. So instead of Ruby having to look at each character individually, Ruby can say like, oh, do these two things point to the same memory location? Yep, they are at the same location in my memory. They are the same thing. They are the same object. Much faster to see like if they are equivalent or not. Much, much faster. Another representation of this like sameness or this immutability is if I say hello to, let's add like, I don't know, some gibberish to it. Hello to, the object ID, still has the same object ID. Let me pull this up. So it like lives at this location that ends at 2660, still lives at that location. So I'm changing this exact string. I'm changing this object. If I try to like change a symbol, I actually don't even think that it will allow me to do this. But if I just like try and add some gibberish to it, yeah, I cannot change it. I cannot change it. If I have another symbol, like I mean, it's just another, it's a whole new thing. If I create this other symbol, hello gibberish, it's its own unique thing. Let's go Sammy and then Brant.
So I'm trying to word this correctly in my head as I speak it out loud. So when you assigned the hello symbol to sim1 and sim2, it didn't overwrite sim1, right? So it's not necessarily like variable reassignment here because it still keeps the same ID for both sim1 and sim2. It doesn't get rid of sim1, right? It has it for both, correct?
Correct. Yeah, so I have two variables, sim1 and sim2, and they're both pointing to the same location in memory.
Okay.
Okay. A thing that if you're really interested in memory and allocation and how variables are used like under the hood, you could look into pass by reference and pass by value. That's a thing that you could look into. I'm not going to go into it at the moment, but in this case, these two variables are pointing to the same location in memory. So two variables pointing to the same object.
Okay, thank you.
Brant.
I'm going to guess the answer is no, but is there a way to access kind of like hello, the word hello within the symbol? I'm thinking of like how a string is a bunch of individual characters. I'm guessing this is a completely different thing. It's its own data type, but I didn't know if there's a way to access like that word hello within the symbol hello.
Not that I know of.
Okay, cool.
Not that I know of. You could like turn that symbol into a string, but it's sort of like, why would you want to do that? Yeah, not that I know of. So we've been talking about all of this like memory stuff and looking things up. The real like guts and reason why symbols are preferred over strings, particularly for things like keys in a hash, is that idea that looking up to see if something is the same memory location is much faster than looking to see if two strings are the same. So when I try and access, let's see if I can, oh shoot, I can't scroll all the way up. Dang it, but I still have my suitcase. Okay, so when I try and access suitcase symbol shirts, it is very quick for Ruby to say, hey, for this object, does that key exist? Like, is that memory location referenced in this hash? Yes, great, super fast. If I'm trying to access the string shirts, these are two different objects. And so Ruby has to compare these two strings to see if the string exists in the hash. So because we're comparing two different objects, it's much slower than saying like, these are the same object, like comparing the same object. Okay. There is like a whole world of research and knowledge that you could go into in this idea of like memory and how things are working under the hood. I would say that I have now shared all the knowledge that I have on this subject with you. So if you have more complex questions, you can feel free to ask me. I probably won't know the answer, but I think like Mike and Bob are both like more knowledgeable on this particular subject than I am. So if you want to post things in the channel, like they can help answer these things for you. I think I'll go back to what I said at the beginning, which is like, or the beginning of this symbol discussion, which is you do not have to have a full 100% like correct understanding of all of this in order to be successful coming out of mod 1. Okay, I think you can even like be a successful developer and not fully understand what's going on here. Okay, Matt.
What's the downside of symbols? Why not use symbols way more than strings? Or is that in fact what we do?
I would say that's in fact what we do. We use symbols way more. I mean, we use strings when we need to, like when we need to return a string that's like highly formatted with spaces and things that we're gonna like send to a user, right? A user doesn't really want to look at a symbol because typically symbols are like word underscore word underscore word, or just like word. You know, strings are helpful for holding on to large chunks of information that need to be passed to a user, because a user can understand like a string much more easily. Symbols are going to be used more in the back end to like compare two things. Like, does the user have this type? Like, are they this specific role? It's going to feel a little bit contrived in mod 1, to be honest with you. We want you to start working with symbols to be comfortable with them as a data type, but it's not really going to feel like, it's going to feel like, I don't know why I have to use this symbol. Why couldn't I just use a string? It's going to be a little contrived.
Thank you.
Joe.
So this is kind of backtracking to iterating over hashes. So if we need to move on, I can post it in the Slack. But I just vaguely remember someone asking a question about when you put in the block variables, sometimes you'll do like an underscore or something for one, and why you would do that. And I think it just confused me more, and I didn't even understand why that's something like a convention that Rubyists will do.
Yeah. So sometimes, particularly when you're iterating over a hash, you might only need to use the key or the value. And so instead of assigning these two variables, which like takes up more processing power for Ruby, like Ruby actually assigns these values each time, you could indicate to Ruby that you don't want to use a thing with an underscore. And so then Ruby's just going to like not do anything with that value as it iterates over. You will only have access to the key in your iteration. I would say this is a thing that is like not super important to know or understand, but yeah, that's what's happening there.
So I shouldn't worry about it, at least for now.
I wouldn't worry about it. Yeah.
Okay.
Yeah, Gunnar.
Well, I had to find everything. Well, that brings up, I guess, another question for me. Could you call a method like dot keys in that instance, or dot values? Or is that something okay, and then like just go off of that rather than just calling like the underscore?
Yeah. So the underscore thing, like, let's step aside from that.
Okay,
I think that's just not really a thing that you need to fully understand at this point. But I think that there is an important piece here, which is that hashes, just like arrays, like there are methods that hashes will respond to. So if I look at like my suitcase and I ask it, hey, what methods do you respond to? I can see like all these methods that it responds to. And one of them is, oh, it would be helpful if I actually sorted these. One of them is, how does the alphabet work? I don't know. Keys. And so keys is a method that you'll see used a lot, where it will give us all the keys in a hash as an array. It will send them all to an array. Similarly, there is a method called values that will give you all the values in a hash in an array. I don't know how useful these two methods are, to be honest. I think they get used a lot more than is strictly necessary. If you find yourself working with a hash and consistently calling hash.keys.something, 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 maybe you don't actually need a hash. Maybe you just need an array with that key information in it. Okay. So I'd say, like, related to that, one common pitfall that I see students doing once we start talking about hashes is trying to use hashes for everything. And hashes are super useful, but they do a specific thing. They hold on to paired bits of information. They hold on to information that has that like key value context. So thing and amount, or I don't know, something else. Thing and array of related things. I don't know. It's like that paired information. And students will try to sort of like make a hash where one doesn't really make a ton of sense. And so if you find yourself trying to create a hash and like really having a hard time determining what should be the key and what should be the value, you probably don't need a hash. It should be very clear that like these are paired pieces of information, key value pairs that you need to keep track of. Yeah. Don't use a hash just because you know about it. Use it when it's appropriate. Cool. Any other questions? Yeah, Joanna.
Okay, this is actually just me literally repeating kind of what you just said, but I just want to make sure. So some pretty good indicators that you could use a hash and it might be successful would be, like you said, you have data that you want to pair together. Mm-hmm. Or if you're like you're seeing a lot of repetition within a collection, within an array. Those are kind of the two.
Yeah.
Okay.
Yep.
Thank you.
Yeah. So if you see something where it's like, hey, student, give me a list of names, that should be an array. A name is a single thing. Versus if you see something like, hey, student, give me a list of names and that person's age. Name and age are now paired together. That maybe should be a hash. Name and age, key value pair. Sarah.
I was just trying a bunch of these methods just to see what would come out. And a message I keep getting is it's requiring an enumerator. Like, for example, suitcase.chunk. I was just curious, like, what would happen?
Yeah.
And I was wondering if you had a short explanation as to like what it's looking for there, just like for future use.
Yeah. So something like this.
Yeah.
Yeah. So this indicates to you that this method chunk should actually take a block. So if I call like suitcase.map or even suitcase.each, it's telling me like, okay, like I called each, but you didn't really give me enough information. Like, I
Yeah.
don't really know what to do. So here's an enumerator. Have fun.
Okay, yeah, thank you.
So it's saying you need like the block. Yeah, great question. Any other questions? Okay, I know I kept y'all sitting here for much longer than we normally do without a POM, so let's end 9 minutes early. All right, I'm gonna